The billion-dollar question, if you follow technology, you have heard the promises, right? Quantum computers are going to cure cancer. They're going to break the internet. They're going to solve climate change. But if you look around, you don't have one on your desk, right? You can't buy one at Best Buy, and your smartphone isn't quantum just yet. So the billion-dollar question is this: when? When does this actually happen? When does a science fiction become science fact? Well, I've been looking at the roadmaps. I'm talking about the internal projections from IBM, Google, IonQ, and the major research labs. And the consensus is actually very clear. This isn't going to be a single iPhone moment where suddenly the world changes overnight. Instead, this technology is going to roll out in three distinctive waves. Now, we're going to break down exactly what happens in each phase and, more importantly, where we are right now in 2026. Now, let's talk about phase one, the hybrid phase. Now, this is the era where we're living in right now. So we call this the hybrid era, or sometimes called the noisy phase or the noisy era. If you read the headlines today, you might think we're close to the finish line. We aren't by any means of the stretching their imagination. Now, right now, quantum computers are incredibly fragile. We call them noisy because the qubits, the quantum version of computed bits, make a lot of errors. Now, imagine trying to solve a complex math problem while you're doing a roller coaster ride. That is what it's like for a quantum computer today. Now, the environment shakes the answer around so much that it's hard to trust the result. So, what are we doing with these machines right now? We aren't replacing classical computers, we are combining them. This is the hybrid approach. We use a massive supercomputer to the heavy lifting to do the heavy lifting, and we hand off tiny specific piece of the problem to a quantum processor. Who is doing this? It's not consumers, right? It's not you or me. Now, you won't see this on your laptop, obviously. It's massive R&D departments. It's aerospace companies trying to simulate airflow over a wing. It's banks trying to model risk in the stock market. They are using those noisy machines to learn the ropes. The goal for this phase isn't world domination. The goal is a milestone called quantum utility. Now, we just want to prove that a quantum computer can do something useful, even if it's small, even if it's niche, cheaper, or faster than a standard computer. Once we hit that, the starting gun officially fires. The bottlenecks, let's go ahead and break that down. Why is this so hard? Now, before we move to phase two, we have to talk about the elephant in the room. Why is this taking so long? Why can't we just build a bigger chip? To get from where we are now to the next level, engineers have to solve three physics problems that are basically nightmares. Problem number one, error correction. Now, remember how I said qubits are fragile? A change in temperature, a vibration from a truck driving by outside, or even a stray ray light can ruin the calculation. To fix this, we need to use thousands of physical qubits just to build a logical qubit that doesn't make mistakes. Now, it's like having a committee of 1,000 people just to make sure one person spells their name correctly. Now, problem number two, cooling. To keep these chips stable, we have to freeze them in temperatures colder than the deep space, right? We're talking about absolute zero. Building a refrigerator that cold, which can also hold thousands of wires, is an engineering marvel. Problem number two, problem number three, scalability. Wiring up millions of these things without them interfering with each other is like trying to untangle a ball of yarn the size of a house. But looking at the charts, we believe we are going to crack these problems. And that brings us to the exciting part, phase two, the advantage era. So around 2028 to 2032, we enter phase two, the advantage era. Now, this is when quantum computing becomes a big thing for corporations. In this window, we expect to see the first fault-tolerant machines. Now, these computers that can catch their own mistakes, when this happens, the impact on specific industries will be massive. First, pharma. Right now, discovering a new drug takes 10 years because we have to guess how molecules will interact. A classical computer can't simulate a caffeine molecule perfectly, it's too complex. But a quantum computer, it follows the laws of quantum mechanics, just like the molecule does. It can simulate nature perfectly. We could see drug discovery times drop from years to weeks. Second, materials. We need better batteries for electric vehicles. We need more efficient solar panels. These are chemistry problems. Phase two is when we discover the materials to build the next generation of energy tech. Third, finance, instant portfolio optimization. Banks will be able to analyze every possible risk scenario in near real time. But notice, I still haven't mentioned you, the consumer. That's because in phase two, this is still a back end industrial revolution. It's changing the products you buy, but not the computer you have or the one that you use. For that, we have to look further. Phase three, the transformative era. This brings us to the part where we're looking at about 2035 and beyond. This is when technology matures enough to become the invisible backbone of the internet, right? At this stage, two massive things happen. One is scary and one is exciting. The one scary part, this is when quantum computers become powerful enough to break RSA encryption. That's the lock. That's the lock that protects your bank account, your emails, and your government secret. By 2035, the entire internet will need to migrate to post-quantum cryptography to stay safe. It's going to be like Y2K on steroids. Now, the exciting part, this is when quantum power hits the consumer. Now, you still won't have a quantum chip in your iPhone 25, which it'll be then. It's too cold, it's too expensive, but you will access it via the cloud. Now, imagine asking your AI assistant, hey, organize my entire life schedule, optimize my commute based on real-time traffic flow, and find the cheapest flight for my vacation. This is a math problem so hard that today's supercomputers would choke on it. But in phase three, your AI will send a request to a quantum server, solve it in a split second, and send the answer back to your phone. It will be seamless. You won't even know you're using it. So let's summarize the timeline. Now, 2027, we are in the lab. Now until 2027, we're in the lab. 2028 to 2032, the corporations take over. We get better drugs, better batteries, and smarter financial markets. 2035 and beyond, it becomes the invisible engine of the world, integrated in cloud and AI. So if you're waiting for the day you can play video games on a quantum computer, don't hold your breath. But if you're waiting for the day quantum computer changes the world economy, get ready because we are closer than you think. Thanks for watching.